Hey, Mani, how are you doing?
Hey, Dinesh.
Yeah, sorry, I thought I didn't remember it was 11:15. I thought it was 11:13.
Oh, okay.
Okay.
Okay, so can you see the team members or are they there?
Recharges, are you here?
Rechargers. Okay, good.
Okay. So let me put them on the spotlight. Awesome. Look at that.
Nice. Okay, so welcome to the first open category championship here. Now, let's start with it's a 10 minutes schedule. It's the first 5 minutes you're going to explain about what you did and all the project, everything that you want me to know. Okay, so then next 5 minutes, it will be like question and answer session. Okay, the time starts now.
Hello, everyone. Good morning. My name is Bharat, and this is my partner,
Jonathan.
And we are the team Rechargers. This year, we've wanted to focus on two main problems, improving reusable energy sources in the household and in transportation. The reusable energy source that we've wanted to focus on was solar energy. And in our models, we included solar panels, which are basically panels that convert the sun's energy into DC power.
As more and more people are moving towards hybrid and electric vehicles, we want to add solar to those vehicles. So we focus on three main flaws of solar panels, which are range anxiety in vehicle use, sedimentation and bird droppings, and excess energy not being used efficiently. Range anxiety is a common problem for many electric car owners. This is caused when the vehicle runs out of range. So this is our first working model. Now, as you can see, we have two solar panels on top and two solar concentrators. Solar concentrators are moved varying on the sun's location. This helps to absorb the sun's rays and reflect it directly onto the solar panel, increasing the efficiency of the solar panel for up to 40%. The energy used will be directly sent to the car to be moving the wheels. And now I'll pass it down to my partner.
And then the excess energy from the car will then go to our generator located right here. And then that energy will light up such things like lights inside the house. And that excess energy that the house does not need will be then given to the community. And we also have our solar panel on top of the house. This will detect if any birds will come near the solar panel, and it will making a beeping ambient noise that will just scare off all the birds away. This will reduce bird droppings on the solar panel, which will reduce dust on the solar panel. And we also have our windshield wiper mechanism that will clean off all the sedimentation and bird droppings. This will make the solar panel more efficient. And now we would like to show us our trifold. You could look to it. We would like to show you our first diagram that we made. This diagram shows us how our plan was to store the solar panel's energy in a battery. And we wanted to do that in our model first, but for design purposes, we just used a 9-volt battery here. But otherwise, we would have tried to connect the solar panel into a rechargeable battery here. And then the solar panel would power all the Arduino mechanisms. And then we also can show us our programming here, which in our program, we use Arduino IDE, and we also commented on most lines. And this is our first code for our ultrasonic sensor.
And now the second code was for our windshield wipers and two servos, and the servos on the vehicle. As you can see, we have the benefits of renewable energy here, and renewable energy generates no emissions. Renewable energy lowers your carbon footprint. There's a lot of positive things about using renewable energy.
And then also we can talk about our design process. In our design process, we first started out with using EV3, and we wanted to make an EV3 car, but we've been doing that for a long time, so we wanted to take it a step farther by using Arduino IDE. So we tried to build an Arduino car, which we somewhat did here. And we also we wanted to use Arduino more and learn more harder code rather than EV3 Mindstorms programming. And also during our design process, we learned many problems with the solar panel, and we had to fiddle with it. And we had to find proper voltage for powering the Arduino and certain motors and vehicles in the car.
Some problems we faced with building the Lego car is that Arduino IDE IDE was a little new to us, so we had to run through a lot of different tests. We had to use motor drivers to control the 4 motors under here, and we had to do various new things that we hadn't done before, so we had a good learning experience as well.
And then we also wanted to focus on what we would improve on. So for next competition, or we wanted to improve on many things, such as actually using the solar panel to like power the Arduino. And also we wanted to make more mechanism changes, such as showing the actual generator through here, powering the Arduino. And thank you for listening to our small presentation, judges.
Okay, thank you. Just a nice presentation. Okay. So you chose 2 categories here, isn't it?
Yeah.
Yes.
Okay, good. Now I have a couple of questions, and why did you, I didn't really get, why did you choose the Arduino instead of EV3?
We wanted to challenge ourselves because in previous years we've been doing FLL and WRO. And in that we would just use EV3 Mindstorms and stuff. And this year we wanted to try out a new breadboard and a new IDE that will help us understand more like technology and develop our like knowledge field.
Okay, got it. Yeah. So have you worked on the cost of implementation, something like that, or?
Yeah, we think cost of implementation will be pretty high at start, but the return of the thing will be come back because in my house we have solar panels, but the over time the cost will then like the cost will pay back, or you in the long run you'll earn more money.
Okay, got it. Now in the vehicle you put the concentrators, isn't it?
Yes.
So now you're saying, so how do you fit the, is it, where is it fitted? Could you focus on that? Show me how it is done, or if you can show it close up, yeah.
So what we have here is 2 solar concentrators, and they'll vary on the sun's location to reflect directly on these 2 solar panels on the top.
Okay.
I also want to like put a servo for the solar panels, so the solar panels will also angle themselves. That's what our future plan would be, to make sure like it will maximize the range of the solar car because it will make it more efficient in the long run.
Okay, you said 40%. So how did you come up with that number?
We did some research on these topics, and we looked at solar farms, and we saw that the percent efficiency is increasing in these areas, and we'll be using weather locations to track the sun's location, so it'll be even more efficient.
To add on to what my partner said, when we looked online, we found like some studies, and also when in nowadays in solar farms, if you know what a solar farm is, it's basically farmland with like solar panels on it. They also have concentrators that concentrate like sun's energy onto them. And from that research, we wanted to add those concentrators onto like a car, which will reduce range anxiety, which is a main problem in modern day electric cars.
Okay, nice. Okay, so is there any ratio between, okay, if there is a solar panel of X size, so what should be the concentrator size or something like that? Have you worked on?
Yeah, it should be like at least 1/3 of the size.
Okay.
It's
now,
the main
okay.
thing.
So how are these concentrators going to affect the aerodynamics of the, or whatever it is, a car, because these are standing outside, isn't it? Yeah.
So our target market would be like rangers, like national parks, park rangers. Their car doesn't need to be that much aerodynamic. Since they're just going in like a forest trail, and it doesn't matter how fast they have to go.
Right.
So they don't have like access to a gas pump in the middle of a forest, right?
Okay.
So this is very helpful for them because they can just power their car through the sun's energy, right? And also we can make it more aerodynamic for people in like civilian usage as well.
Okay, that's fine. Good enough. Okay, now instead of the concentrators, if you can make those as the panel, solar panel also, do you think the energy will be more or less?
It would still be the same amount of energy as the solar panel being normal, but it will be a little more. But I think the percentage given off with the concentrator is more like efficient than having solar panels itself moving.
All right. So now let me come back to the home energy. So here, so you said you're using the bird. You're checking if the birds are there. You're sending the sound or something, right? Okay. So now, do you use any sensors to that, or how do you find out if there is a bird?
We have an ultrasonic Arduino sensor.
And then we also have a buzzer.
And we also have like an Arduino buzzer.
Okay. Oh, got it. Okay. Now, bird sensors. Okay. So what are the different sensors you're using in this?
So first we have an ultrasonic sensor.
Okay.
And we have 2 servos.
And then if you can see under our core,
We have 4
we have 4 DC motors and an Arduino IDE shield.
and a motor.
It's a motor driver shield that will shield this basically shields the Arduino from any voltage problems. We fiddled with that and it helped us a lot.
Okay, so now, how about the program? So how could you just explain me what all the different new technologies used to be comparing to your EVT programs when you moved to Arduino? Tell me what you learned or something.
The main difference is we had to use not block-based coding.
Okay.
We had to write our code, and we found like helpful tutorials online that. So the main difference is at the beginning we had to state our variables, and like EV3 we don't have to do that. And also another struggle we went through when coding the servo wiper system. It's very different than like a servo motor on an EV3 because it's like 180 degrees and each like location is marked as a degree. As a servo in a EV3 servo, it's like normal, and you can like put 90 degrees and it'll just go back to where it was. However, here you need to put a different degree to where you want to return to where it's going to go back.
Got it. Okay, good job. Already. Thank you for your time.
Thank you.
All right, bye.
Great job, rechargers. Okay. Yep. Okay.
Thank you.
Okay, so you can stop recording it now. Or
1 sec. Let me stop recording.
and stop the live stream.